Hey guys, here's a short video. This is the introduction to it. This is one that I recorded a while back and have re-edited for your use in AP. See if you can spot the subtle visual cues that will tell you when I actually recorded this thing. Anyway, this is about shockwave diagrams and how to make shockwave diagrams, how to interpret them, and then if you're stuck at home and you don't have a centimeter ruler, I show you right at the end how to deal with that, how to make your own ruler, basically. So anyway, yeah, here it is. Hey guys, today we're going to learn about how to make shockwave diagrams. Last time we talked about shockwaves and wakes, and I told you that this time we'd learn how to do this. So it turns out that you can look at a picture of a shockwave and figure out how fast the object is moving. And today we'll be thinking about aircraft and rockets going through air. So as we said last time, the angle here of the wake that an object makes when it's going faster than the waves it makes, the angle of that wake gets sharper the faster the thing is going. And today we're going to learn about Mach number and how that corresponds to these images of shock waves. Okay, so first we probably need to talk about what a Mach number is, since that's what we're going to be working with here. Okay, a Mach number is named after a guy named Ernst Mach, who was a German physicist who figured a lot of this stuff out. And it is simply a ratio. Mach number is the ratio of the speed of the aircraft compared to the speed of sound. So if the aircraft is moving faster than sound, then it's going to make a wedge-shaped or a conical shock wave like this. And the faster it's going, the sharper that shock wave is. So what we're going to do is we're going to compare the speed of the plane in a situation to how fast the sound is going. Okay, so we're going to use this one. And remember now, the airplane makes sound when it's in any place. So right at this moment here, it's making sound, and we're for convenience for using the tip of the nose. And it's making sound, but since no time has passed, the sound hasn't gone anywhere. And the farther back behind the plane is, the farther the sound has been able to spread out in all directions. So we're choosing, just for convenience, this spot right here. And we're looking at the red dot, and we're saying, okay, when the airplane was at that position, so when we back up the plane and we put the plane in that position, the plane made sound. And that sound has been expanding outward in a circle ever since. Really a sphere, but on our diagram, it's going to be a circle. Okay, so it's expanding and expanding and expanding, as we saw in that moving animation last time with the plane that was flying subsonic and just at the speed of sound and then supersonic. These circles expand as the plane moves forward. Anyway, this circle has expanded so it is this big at this moment in time when the plane has reached this position here. So if we measure that, we can see that the sound has gone 1 unit of distance. Maybe it's a mile, maybe it's a 1 foot, whatever it is, but it's gone 1 unit of distance. And in that same amount of time, the airplane has gone 3 units of distance. It's gone to here and this far again. So the airplane has gone 3 units of distance, while the sound has gone 1 unit of distance. And Mach number is the ratio of the speed of the plane to the speed of sound. So this plane is going Mach 3. Okay, and this cone here is a cone. This wedge, this angle, is the angle that you get for anything that is going Mach 3. Now, your homework, I'm going to show you how to make these. I'm going to go step by step how to go through these. But your homework for today is going to be to create shockwave diagrams for an aircraft that is going Mach 5, another one for Mach 4, one for Mach 3, Mach 2, and finally for Mach 1. Okay, that's your homework for today, and I'll show that to you again in a second. But yeah, that's your homework. Make shockwave diagrams for Mach 5, 4, 3, 2, and 1. You need to be able to create the diagrams. So if I say create a Mach 3 diagram, you have to be able to come up with something that looks like this. And you have to be able to look at a diagram and be able to figure out what the Mach number is. It's actually pretty easy. So I'm going to show that to you right now. Okay, so for this, you need a penny and you need a ruler with centimeters on it. Okay, if you don't have a penny or a ruler with centimeters on it, you can use any circular object like a ketchup off the top off a ketchup bottle or a quarter or some washer or something like that. And then we can create a ruler. And I will show you that at the end of this. But first I'm going to show you how to do this for a penny and a centimeter ruler. Now, why do we use a penny? Because it turns out that if you draw a circle around a penny, pretty close, that circle will be almost exactly 2 centimeters in diameter. See that? So if we put a dot on here, that means that the radius of the circle that's drawn around a penny is 1 centimeter. And that's very convenient for us. So what we're going to do is we're going to draw a line through the center of that circle that we made. There we go. We're going to be as precise with it as we can. Okay. So this circle represents the sound that the aircraft made when it was at that point. And since the plane was there, the sound has been expanding in all directions at the speed of sound. But meanwhile, the plane is going faster than sound. So if we want to do, say, Mach 3, that means that you know what, I'm going to do it this way so that we can, so that we're counting up and not down. It's fine. Okay, so when the plane was here, it made sound. And in the 1 second since then, the sound has traveled this far. It's gone a radius of 1. But in that same amount of time, the airplane has gone 3 because we're choosing Mach 3. Okay, this is for Mach 3. All right, so we're going to put a dot up here at 3 centimeters from the center of that circle. So the sound has traveled 1 centimeter and the plane has traveled 3 centimeters. And as you know, these shockwave diagrams come out to be straight line from the nose of the plane to just touching that circle. So we'll do that, draw lines that are just touching the circle. There it is. That is a shockwave diagram for Mach 3. Now we can do this backwards as well. If I give you this diagram and ask you, hey, what's the Mach number of this plane? What you do is, and I often will not give you the circle, okay? I'll just give you this cone. Well, you know what? I'm just going to do it. I would give you something like this. I'm going to make it so it is. I want to make this symmetrical so that it isn't all lopsided on us. There we go. So I might give you something like this. Now, the one I give you will generally be round numbers. This particular example, as you see, I'm just sketching it on here, so it may not be a round number. But I may give you this and say, what's the Mach number? Mach equals, and you need to find it. Okay, so here's what you do. You put your penny within the wedge, and you place it so that when you draw a circle around that penny, it will just touch the wedge. See that? That's what you do. Now you have a circular pattern just like this. You find the center of the penny. It's right about there. And now you measure. Now you know that the radius of the penny is 1 centimeter, so that makes it easy. And this one comes out to be about 3.25. Okay, about 3.25. So this would be Mach 3.25 because this distance was 3.25 centimeters. And this distance was 1 centimeter. So the ratio of how far the sound went compared to how far the plane went, or the plane to the sound, is 3.25 to 1. Now the ones that I give you will generally be nice round numbers. This one came out a little bit odd, but the principle is the same. Okay, so to summarize, you draw a line, you draw a circle around your penny, so that it is centered on the line. You mark the center, and then you say, well, what Mach number do they want us to give you? What do we want you to give us? And I'm going to say Mach 2 on this one, Mach 2. So I'm going to measure 2 centimeters. 2 centimeters from the center of the circle because the plane went 2 centimeters when the sound went only 1. So that's where the nose of the plane is. And then we will draw our circles, draw our lines to the edge of the circle. Fairly close. And that's it. That's a Mach 2 diagram. That's all there is to it. Okay, what if you don't have a penny or you don't have a centimeter ruler? Well, you have to use something else, right? How about a nickel or a quarter or a washer, something like that? So here's what you do. You draw a circle all the way around it, whatever object you have. Okay. Then you take a piece of blank paper. You're basically going to make your own ruler out of this. Fold it in half, and then in quarters again, and then you're going to make marks on this to mark the diameter. Now it's also useful to draw a line through the center of this so that you're consistent, so you have something to measure along. Okay, so now you have 2 marks that are the diameter of the thing. Then you put one of those marks on the center of the circle and draw 2 more. Now you have a ruler that has the radius of your circle, and you can make it as many marks as you want with that. Okay, and now you have a ruler which is custom made for whatever circular object you have. And now you do the same thing. If you want to do a Mach 3, 1, 2, 3, there's the plane was here at the center of the circle. It's moved 3 units, 1, 2, 3, and draw a long tangent to the edge of the circle. And there's your Mach 3 diagram. If we give you this, give you the wedge, you take whatever circle you have, you lay it so it's just touching, draw the circle all around it, use your same ruler and measure and say, okay, the sound went 1 unit and the plane went 3 units. So this is Mach 3. That's it. All right. So we learned what Mach number is. We learned how to make shockwave diagrams. We learned how to interpret shockwave diagrams. And that's enough for one day. So once again, your homework is to create shockwave diagrams for Mach 5, Mach 4, Mach 3, Mach 2, and Mach 1. The Mach 1 one is a little bit tricky, but remember, all these shockwave diagrams that you make, you have a line which is touching the nose of the plane and is tangent to the circle on each side. And the slower it goes, the more vertical it gets. Okay? All right, have a great day. We'll see you next time.